Suppose you are a researcher in a hospital. You are experimenting with a new tranquilizer. You collect data from a random sample of 12 patients. The period of effectiveness of the tranquilizer for each patient in hours is as follows. What is a point estimate for the population mean length of time? So all that's really asking for is what's the mean of this data. So to find the mean of the data, let's put it into the calculator. I will go under Stat and Edit to put it into a list. And I've got some things in this list editor, so I'm going to clear some stuff out. Okay, so this is just a single set of data, so I'm going to place everything into L1. So I'll just type it as quickly as I can so that we can move forward. 2.8. Oh, come on now. Okay, so data is in. Now to get the point estimate, which is just the sample mean, I can use the one-var stats. So stat, slide over to calc, one-var stats. The list here is the data in L1, and the frequency list I'll leave blank because I don't have any frequencies. If you didn't see this menu, that's okay. Just type second and 1 at this point and press enter. And you'll get the same results. So 2.49. I'll take it to, oh, it's at 4 decimals. All right, so 2.4917. All right, what must be true in order to construct a confidence interval in this situation? Well, in order to be able to construct a confidence interval, we need to be certain that the central limit theorem is satisfied. So one of two things needs to happen there. So either we need to have a large sample, which we don't. We have 12 patients. We'd have to have 30 or more to have a large sample. So that's not happening for us. What we would need then is the central limit theorem is also satisfied if you have a distribution that's normally distributed or approximately normal from the start. So the distribution must be approximately normal. All right, now it doesn't state that in the problem, but we're going to make that assumption and then move on so we can answer part C. Construct a 98% confidence interval for the population mean length of time. Enter your answer as an open interval, so with parentheses, and we'll round our upper and lower bounds to 4 decimal places, although that's a bit strange of a instruction there. You should generally round to the same accuracy as your data. So the data is to 1 decimal. Everything really should be to 1 decimal, but we'll follow the instructions here. That's fine. Okay, so since we have a small interval, what we're going to use is since we have a small sample, what we're going to use is the t-interval function. So you have a choice between t-interval and z-interval. When we have a small sample, we use t-interval. All right, now the data. We can either pull the data from stats or from the actual data itself. So I'm going to pull the data from where I have it stored in L1. So I'm switching over to data mode. I don't have any frequency values, so I think you can clear this or just, I guess you have to put in a 1, so that's fine. Level of confidence, we want a 98% confidence interval. So we do that and hit calculate, and it will come up with the mean standard deviation, sample size, all of that information that it would have needed otherwise from the sample data itself, and then calculates the confidence interval for us. So we have 2.2337, because it did say to use 4 decimals, and 2.7497. All right, a couple of additional problems here. What does it mean to be 98% confidence in this problem? The confidence interval contains 98% of all sample times. 98% of all confidence intervals found using this same sampling technique will contain the population mean time. 98% of all times will fall within this interval. And there's a 98% chance that the confidence interval contains the population mean time. So the thing that you have to separate yourself when it comes to confidence intervals is you're not really calculating probabilities. So there's really not the idea of chance here. So we can sort of throw that out just because of that. 98% of all times will fall within this interval. That's sort of basically a probability. So that's thrown out as well. The confidence interval contains 98% of all sample times. That's not really necessarily true either. The one thing that you need to understand when it comes to confidence intervals is that if you constructed a whole bunch of confidence intervals, like say you constructed 100 confidence intervals, if you have 98% confidence in your results, then 100 similarly constructed confidence intervals would contain the population mean. So that is how we interpret these, and that's basically what's being stated in part B. Lastly, suppose that the company releases a statement that the mean time for all patients is 2 hours. Is this possible, and is it likely? Well, let's take a look at the confidence interval. So the confidence interval says, we have a 98% confidence interval of 2.2 to 2.7. It's not impossible that the mean time for all patients would be 2 hours. So is this possible? Yes. But it's pretty far outside of our confidence interval. So is it likely? No. So that's how we interpret that.